Yeah, so this is a trial of a new setup I'm trying, and today I wanted to talk about briefly about insulin and how it works, why it works the way it does. And to start with, insulin is what actually knows the glucose of your blood. So when you after a meal, you have a lot of glucose hitting you. Insulin counters that. But I made this as a farm, but you can think of as bananas or coconuts or whatever you want to talk about. But some kind of fruit or some kind of product on an island. Um, so DC would be the pancreas that has the beta, alpha, and gamma cells, and they all have a variety of functions. So beta is what makes the insulin. So insulin, if, like I said, being a fruit, but it's really opposite of fruit, um, comes in bundles of 30 and 50, 30 and 21. So there's 30 and a 21, and they're combined by a disulfide bond. You could think of it as vines, but when you send fruit, you don't just send one or two or three. You send a whole bundle, right? And you package them, and you could wrap it organically, right, with vines. The alpha cells, is kind of what takes care of the farm. In that, some sugar is used to make it start it. It also takes it back and it transports it, right? So it goes to the muscle, liver, and other tissues. While the gamma is the regulator of it. You see a guy, you put a monocle on him, and so the shipment of this fruit or product here from the C from the products of beta cells contr- um, controlled and moved out by the alpha in the C of the pancreas, sends to the muscle, liver, and everywhere else fat. It's a whole system, whole ecosystem here, but where it goes is what's important. And the way it gets there is from the mode of insulin, that the type of insulin that it has. So you could think of you could think of rapid acting insulin as a speedboat, and on the other side of that, you could think of a cargo boat, a cargo ship. So one's really fast and one's really slow, but the slow one carries more that you could use. So just some high yield. These are about top six types of insulin used, but main categories are rapid, intermediate, and long. Um, the way that rapid acting works is that in Lysopro, it swaps proline and lysines. So there's two proline lysines on the chain, right? Of this chain, there's two swapping of the amino acids, and makes it exist more as monomers, and that's how all these rapid work, but in different way of how they do that. But the rapid switch swaps the proline and lysines. It's less stable and exists more as monomers and hits the blood quickly in about 10 minutes or so, and it lasts about 4 hours. That's more so how a lot of these are. Aspartate, it makes proline into aspartic acid, so the negative charge breaks it. It makes it repulse itself inside internally, and so it's used very fast. And then this glue lysine, it makes an asparage into a lysine and another lysine into glutamic acid, and this leaves a positive and negative charge on the surface. So that's how they break down or keep from becoming dimers. This is how this one becomes from becoming dimers. The intermediate acting, this NPH, um, the structure isn't so much changed, but it is combined with protamine, and that's arginine-rich amino acid, and that makes it into crystals. So insulin, protamine, and zinc make crystals that dissolve more or less in 12 hours, or last for 12 hours, but they dissolve slowly. Then there's long acting, and these use glargine and adds arginine amino acids to raise the isoelectric point, and these form a lot of really small crystals. And then there's detamere, and so these are more of the shipping, right? Because these last about 20 hours or 24 hours. Intermediate is about 12 hours, and then rapid lasts about 4 hours. So the speed is based on how the a few changes make make insulin, this product, different. This is a few swaps usually. This is adding a few things. So long acting in detamere, it adds a fatty acid. I think it's from stearic acid, and that allows for the bindings up to reversible binding to albumin of blood and the subcutaneous tissue. There's another few like that, but this is just the main variety of these. But long acting, you think of longer acting, usually make crystals or have reversible binding to albumin. Because there's another I can think of that also does this. I think it's a difatty acid. But they bind to either albumin of the blood or they form crystals. That's usually how longer or intermediate working insulin work. While the rapid acting insulin, mm, learn how to be less stable or how to keep themselves from becoming larger, to break down faster, to dissolve in the blood faster. And something to think about. So insulin resistance, you could think of the transport, right? Of this transport of these modes getting to the port. Think of the product getting to a port, but not being able to cross into the gate of a port of the where its arrival. That's what insulin resistance is. So if you travel to destination and the gate and port don't allow for its arrival, what do? Right? That's a problem. So that's what insulin resistance is like. Right? So think that's high yield for what diabetes basically is. And so when insulin gets to the muscle and fat, what do? And that's I'll probably leave it off as that for today. So insulin is sugar, right? This isn't actually sugar. This is insulin. Thanks.